Hello everyone and welcome to today's presentation. It's in Applied Movement Analysis. I'm Mohammed, and today I will be presenting uh, my bit of presentation regarding the biomechanical kinetics and kinematics of a movement. Moving on to the outline, so we can see there are four key points. The first point is the preparation, where we're gonna see the athlete, the movement and the phase that we will be analyzing. The second part is the observation. We're gonna have a look at the joints, articulation, bones, movement produced, agonist muscles, type of muscular contraction, movement axis and plane of movement. Third, we're gonna see an evaluation and diagnosis. And the last thing is an intervention. So moving on to the first part. So my athlete is Yusuf. He's a third year bachelor sports coaching student, and he plays football from time to time. Also, he runs. He's an amateur runner. So the next second, we can see the posture analysis of Yusuf. Is kyphosis lordosis posture. As we can see, according to the literature mentioned below, so the pelvis is titled anteriorly, and the flexion occurs in the hip joint, which increases the forward arching in the lumbar spine, and the flexion in the thoracic spine, which is kyphosis. Um, Third, we can see the movement that we will be analyzing is running, and the motion of running that we will be analyzing is jogging from 8 to 10 kilometers per hour. Moving on to the next slide, so the phase of movement is running, as you can see, and the phase that we will be analyzing according to the gait cycle is stance phase, where there is a full contact with the ground. Moving on to the joint and articulation bones part, the ones written in white are joints, and the ones written in black are bones. So we can see the pivot joint is from the neck, glenohumeral joint is for the shoulder, elbow joint, hip joint, which is very important in running, and subtalar joint. So the bones are tibia, patella, pubis is the bone, that is between the hamstring and the quadriceps, fibula and plantar fascia, which is like the bone in the lower part of the foot. Moving on to the movement produced, according to Poleo and Gash, the movement produced in this phase is the subtalar joint invert and evert, the midfoot abduct or adduct, the forefoot doriflex and plantar flex. We can see a knee flexion from the right foot and an extension from the left foot. Arms are bent like 90 degrees at the elbow, both arms, and also the arms are swing forward and backwards, are like pendulum. And the last thing is the construction of the hamstring from the first leg, and which gonna go to the another cycle, which will start like constructing the hamstring for the second leg. Moving on to the next part is agonist muscles and type of muscular constructions. According to Gash, there are four muscular contractions. So the first is isometric, a change in the tension without a change in the muscular length. Isotonic is a constant change in a muscle tension without change in a muscle length. So the difference between isometric and isotonic is that isotonic is a constant change. Isometric is not constant. It's just for the moment where we apply the tension, basically. Uh, Concentric is a muscle contracts and shortens for example, the biceps, and eccentric contraction act as a braking force in opposition to concentric contractions to protect the joint from the damage. For example, the biceps and the triceps. The bicep muscle is concentric, the triceps muscle is eccentric, the right leg, the quadriceps, is concentric, and the hamstring is eccentric. Moving on to the next slide, we have the movement axis and plane of movement. According to John, there are three plane of movements. So the sagittal axis, which passes horizontally from posterior to anterior and is formed by the intersection of the sagittal and transverse plane. The frontal axis passes horizontally from left to right and is formed by the intersection of the frontal and transverse plane. The vertical axis passes vertically from the inferior to superior and is informed by intersection of the sagittal and frontal plane. And as you can see in the picture on the right, we can see that there is the X and the Y. So the Z basically is just like going through Yusuf to the other side. So I cannot draw it because it cannot make it a 3D, but I hope it's clear for you guys. So moving on to the next slide is analyzing of Yusuf running. According to Rachel and Terian, there are three main categories of foot strike. There is a rear foot strike and mid foot strike and forefoot strike. So the rear foot strike is when the runner, the first contact with the ground is by the heel. The mid foot strike is when they try to contact the first contact of the foot is nearly by the mid of the foot, and the forefoot strike is the point of contact of the forefoot. So according to the picture attached, we can clearly see that Yusuf has a rear foot strike. Will this be impacting his running technique? So this is what we're gonna see in the next slide. So according to Brady and Lieberman, so the rear foot strike has some disadvantages. First, it increases a braking force and as the foot land close to the center of the mass of the body. Second, the athlete loses some of the momentum energy, which we have the formula. It's P give us mv. M is the mass and V is the volume. And I wrote there an example. For example, Rizov is running like 8 kilometers per hour, which is the jogging pace. And the volume from 8 kilometers per hour, we're gonna convert it to meter per second, which is 2.22 meter per second. So P is gonna be 70 times 2.22, which is gonna give us 155.4 kilogram kilogram time meter per second. So this is the unit of the momentum energy, and this momentum energy is gonna be decreased because bit by bit, because as it's mentioned, the foot strike is closer to the center of body mass, and this gonna makes Yusuf or all like the runners of who have rear foot strike to make more efforts to move forward to the next cycle. Third, we have calf pain. Fourth, we have hamstring tendinopathy, which is an inflammation in the tendon. Fifth, we have TBS absorbing higher forces. Moving on to the next slide. We have the loading rate according to Therian. So it was a research that you can see the numbers there indicating of the loading rates of 6 different scenarios. So first we have a barefoot with a rear foot contact, which has the highest loading rate. Second, we have a rear foot with a low absorption shoe. followed by a rare foot contact with a high absorption shoe, forefoot contact with a low absorption shoe, forefoot contact with a high absorption shoe, and barefoot with a forefoot contact. So we can clearly see that the forefoot contact will have the less absorption, will have like the less loading rate comparing to rear foot contacts. Moving on to Hamill and Gruber, changing the foot strike has no obvious benefits for majority of runners, and changing the foot strike might stress tissues that is normally stressed when running with a habitual pattern, and also changing foot strike should not be recommended to amateur runners according to biomechanical, physiological, and epidemiological literature. So basically, I'm not. My intervention is not going to change use of foot strike, but instead my intervention is gonna be about the shoes. So this is my intervention. So the appropriate footwear according to Cook and Park, appropriate footwear and use of energy absorbing materials to help dissipate the shock will benefit from these individuals. Many symptoms of knee disorder in runners were related to the increase of the distance, speed, change of the surface, or change of the running shoe. So the running shoes play a big impact here. That's what we're gonna see in the picture attached. So there is a perception retention, and there we have miles. So this is a percent retention of initial shock absorption as function of a mileage for a machine. As we can clearly see that first when we have 0 miles, so the absorption for the shoes it was 100%, but just after 50 miles nearly, so we can see there is a decrease, and also there is like a sharp decrease from the last line. There is a sharp decrease of the absorption, which indicates that the shoe they have like a normal kilometers that the runner needs to use it for. It depends on the shoe and it depends on the manufacturer. For example, Shams shoes can last for 200 miles, so others can last for 500 miles. So my intervention is to request Yusuf to get appropriate shoes that helps him to absorb the shock, and also I request him to use the surface for example not Alzeft or concrete, because the shock there is gonna be higher. So using like a green surface is gonna be the shock is gonna be a bit less, um, and that's all. Thank you for listening, and this is my bibliography, and thank you.